Good day, everyone. Welcome to Chemistry with Professor John. This is part two of the homework set one of Organic Chemistry 1. That's Chem 281. Okay? Doesn't matter what um, the course name is, it's the topics. That matters, right? Okay, this is part two, so we'll be focusing on alkanes, everyone. Alkanes, okay? This is a continuation of alkanes. That's the simplest hydrocarbons with only single bonds. Okay. Now talk about reaction. You guys saw the reactions. Only a couple reactions in the study guide. Well, the first one here is the combustion reactions of methane. Okay. And that's what we have at home. Alternative natural gas is mostly methane, CH4. They're cheap, like 70%, and then the rest are probably propane, ethanes. Okay, so when you burn methane, this is the balance equation. You got CO2 and water, and the heat release is 800 kilojoule per mole. Not as much as propane, but they're cheap. Okay, so it's good. Now, the second reaction is halogenations. And if you take any alkanes like CH4, the methane, you react with chlorine gas in the presence of UV light or heat. That's energy source. You get chlorinated methane. That's chloromethane. If you do it again with more, if you have more chlorine, then it's keep going to the next one and the next one, and it can go up all the way up to CCl4, replacing all four hydrogens. Okay. Now, cracking, and then we look at that. Cracking is like breaking up big molecules of alkane into two or more smaller molecules. Okay. Now, conformation, as you remember, we got the front carbon and the back carbon is a circle. So you see this stuff again, right? And you have a Starger or anctide in this case. Totally, the two big branches are opposite. And then you have eclipse, that's closest one. So eclipse is the least stable, and if you spread them out far away, that would be the most stable, the Starger, or also known as the anctide. Okay, now here's interesting facts. Gasoline, the gasoline that we put in our car, has an approximation of about 15% C4 to C8. So that's hydrocarbon alkane, contain 4 carbon to 8 carbon, 25 to 40% C4 to C10 alkanes, 10% cyclic alkane, that's cycloalkanes, and 10% straight chain alkanes, and 25% arenes, meaning aromatic compound. Okay, like with benzene or toluenes. Okay, so here's a couple examples. You guys can go through them and check it out. 1, 2, 3. Oops, 3. That's 4, and that's 5. And then you got a brand, you got a brand, you got a brand, you got trimethyl. Okay, so that's why it's 2,2,4 trimethylpentane. All right, cycloalkane, as you saw in the study guide, and here's a quick review. We got cyclopropane, got cyclobutane. It's a little square. Well, each of them is a CH2. Notice each carbon is always a CH2. Okay, now that look like a pentagon, but for us it's cyclopentane. That look like a hexagon, but for us it's cyclohexane. Now, if you have only one branch, that would be methyl cyclopentane. You don't have to number because it's always number 1. If you have a 4 carbon on one side and you have a 3 carbon ring on the other side, it's only fair to make the 4 carbon a butane. And this case we have to number 1, 2, 3, 4 because it's a straight chain. It can be anywhere. In this case, it's at carbon number 1. So that's why it's a 1-cyclopropyl-butane. Now here's a few more examples. What to do and what not to do. No, okay? The numbering, you want to put number 1 on the first one of the branches, and then the second one's got to be closer. And that's why the best way is 1 this way. 1, 2, 3, 4. Okay, so you got 1 and the second one is 2, and 3 and 4. If you do any other way, the first 2 are the same in this case, but the last brand is number 6, so that's too far. Okay, so anyway, with that correct numbering, this come out to be 2-ethyl 1,4-dimethylcycloheptane. Okay, very good example from the book. And we got a few more examples here for you guys to check it out, what to do and what not to do, okay, in terms of numbering. Okay, here's the one that we got to go over together because there's no answer for this. So that's 1, 2, 3, 4, 5, 6. Doesn't matter which way you go, clockwise or counterclockwise, the 2 methyl always end up 1 and 4. So 1,4-dimethyl cyclohexane. Okay, now this one will be methyl and propyl. So M should go before P, so that's why it's 1 methyl, 3 propyl, cyclopentane. Okay. Now this next one is very interesting. Okay. Now it would be a lot easier if we use the straight one as a main compound and the cyclo is the branch. It's a cyclobutane if it's by itself, the square, but if it's a brand, it's cyclo 3 cyclo butyl pentane. Okay, that's a lot easier. Plus, you got 5 carbon pentane and it should be the main chain versus the 4 carbon cyclo. In this case, we have bromo go before ethyl. So that's ethyl, that's bromo. So that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that should be a 1 bromo, a 4 ethyl, cyclo, 10 is decan. Okay. All right. Now, this is a CH with a 2-methyl. That's a isopropyl, and that's a methyl. Isopropyl and methyl, iso, I go before M, so 1, 2. So that would be 1 isopropyl, 2 methyl, and this is a 6 carbon. It's a hexagon, so it's cyclohexane. Okay, next, numbering is so important. That looks like an T-butyl. That's a methyl and that's a bromo. Now, numbering is important. So number 1 can be anywhere, but here is the best one because number 2, you got the next branch right next to it. And 3 and 4. So that's the closest you can get. 5, 6, 7, right? If you go the other way, it's further for the bromo. Now, even though bromo go 4, just because of the locations, even though it go 4, they still have to go first. in the when you write the name because that's bromo. Okay, now the second one would be 1T-butyl. Okay, they're really close. They both start with B, but U come after R, so that's why the R beat the U. Okay, now T doesn't count because T is just say tertiary. It's a prefix. And then you got a 2-methyl, and this is cycloheptane. Okay, let me know if you come up with a different name and you want me to check. Okay, now so those naming from given structure. Now we got the name and we need to draw the structure. That's actually a lot easier. You always start out from the last word, which is cyclooctane. So we know it's 8. That's, let's say 1, 2, 3, 4, 5, 6, 7, 8. It doesn't matter where you start number 1. So we got 1,1 dimethyl. So 1,1 dimethyl. That's it. 1,1 dimethyl. 1 stick, 2 stick, done. Cyclobutylhexane. Hexane means 6. 1, 2, 3, 4, 5, 6, and then cyclobutyl. That look like a square. Cyclobutyl. 3 cyclobutylhexane. Cyclo again, pentane. That's a 5, and it's a 1, 2. So again, doesn't matter when you put 1, 2, 3, 4, 5. 1, 2 dichloro. So 1 chloro, 2 chloro. That make it a 1, 2 dichloro. Cyclopentane. Cyclohexane. That's a hexagon. And we have 1, 3 dibromo 5 methyl. So let's say 1, 2, 3, 4, 5, 6. So 1, 3 dibromo 5 methyl. Okay, that's it. You can write a CH3 as a methyl, or you don't have to. That means there's a methyl there. All right. Okay. That's end the practice, additional practice, and then you got the discussion assignment. This is your homework, and please give a try on the homework and check out the answer key. I post the answer key on Canvas. Okay, check out the answer key, but you should try them by yourself first. All of this before you check out answer key. Okay, thank you guys. This is again homework set number 1, part 2, and pretty good. That's should be good and ready for the first exam. Okay, let's do well and get a good momentum to move on to the next part. This is actually in the books, it say chapter 1 to 3, but actually from our textbook, it's chapter 1 to 4. Okay, because they break down chapter 3 alkane into 3 and 4. Okay, everyone, thank you for watching, and see you guys soon.